Hi everyone. I'll be covering a couple of questions in this video. The first question is a basic idea on average speed. The question tells us a person walks half the distance as 4 km per hour and the remaining half at 5 km per hour. Find the average speed of the person for the whole journey. Now, usually I've seen people use harmonic mean, arithmetic mean. There is no harm in using that if you are aware of why so. But let me tell you, you don't actually have to, because first of all, if you have a straightforward question like this, it can be solved very easily without using any concept as such. And more often than not, if you have a variation on it, so for example, if it's not exactly the same distance for the two parts, so for this case, half the distance at this and half the distance for this, meaning whatever distance this person has covered for 4 km per hour, it's covering the same distance, 5 km per hour, because this is half the distance, is also half the distance, right? If you don't have that, you can apply this logic, what I'm going to use for this question, very simple logic, and just figure out the answer. So what I'm going to do is I'm just going to assume some numbers for the distances, just keeping the relationship intact. So you don't have to actually draw the diagram. This is just an explanation. My target is to get the times in integer. So the speeds are given to me. We have one part in 4 km per hour and the other part at 5 km per hour. I'll assume the distances such as the times that we get in both the cases are integer values. So I'll just assume the distance to be 20 for each of the parts. Then 20 is divisible by 4 because distance by speed is time. And I'll get the time in integer values. That's it. So average speed, the basic concept, total distance by total time. Total distance covered is 40 kilometers. Total time taken is 9 hours. Average speed 40 by 9. That is roughly 4.44 km per hour. That's it. So whenever you have a question like this, just keep in mind that you have to assume the distance relationship. Assume the numbers as that the distance relationship that has been given is intact. So just a small variation. I'm not using a different question body for this. I'm just going to make some adjustment here. So instead of half the distance, let's say it was 1/3 the distance. Let me just write this a bit properly. So instead of half the distance, let's say it's 1/3 the distance at 4 km per hour, and the remaining distance, so that would be 2/3 of the distance at 5 km per hour. So in this case, the only adjustment, so I'm not going to draw the diagram in this case. You can just understand straight away. So 4 km per hour, 5 km per hour. Now the objective is to give the times in integers. Why so? It helps in calculation, becomes easy to calculate with. So instead of using 20/20, I cannot do that anymore because it's not the same distance in both the cases. So instead of doing that, I am going to use some multiples of 20 because then, it will be divisible by 4 and 5, but maintaining the distance ratio. What is the distance ratio? The first part is 1/3. The second part, obviously 2/3. So the distance ratio is 1:2. So I have to keep multiples of 20 in the ratio 1:2. So if I take 20 and 40, both are multiples of 20 and maintains the ratio 1:2. That does our job. So 20 by 4, you have 5 hours. 40 by 5, that is 8 hours. You have 20 plus 40, 60 upon 13 should give us it would be roughly 4.6 something kilometer per hour. So just use this idea. It's a very simple idea. So by the way, for this case, if you have to use harmonic mean, it becomes complicated. You have to divide the second part into 2 parts, and then you have to apply harmonic mean on 3 numbers, 4, 5, and 5. If you don't understand that concept, don't go into that. Better use a simple idea, and that's it. You get the answer. So that's it for this problem. Let's move to the next one. Here, it's a basic concept again. It's a concept of one object passing another object where both the objects are moving, or one of the objects are moving, the other is stationary, whatever it is. When one object crosses another object. So for instance, in this case, we have a train, which is whatever length, whatever biggest length, and passes a man. Now, realistically, the man will have a certain length, but that will be negligible in terms of, the train that is 100 meters or whatever. So you can realistically consider the man to be just a point. So first of all, assume the man to be stationary and imagine this particular scenario. So what does it mean to pass a man? It is from this scenario to this scenario, right? So that is where the train completely passes the man. So from the point at which the starting bit of the train is meeting the man to the point where the end of the train is meeting the man, something like that. So that is when you pass the other object. Now, in this kind of cases, so I'll just elaborate this not with a man first. So if you have one object passing another object, so the other object being stationary or moving, whatever, just forget about it as of now. It is from this scenario to this scenario. So imagine it from any one of the points on the body of this particular object. So let's say the back of this object reaches this point, right? So essentially, how much distance does this back of the object has to travel? It has to cover its own length plus the length of the object it is trying to pass. So essentially, whenever one object is crossing another object or passing another object, it's basically the distance covered, the distance that needs to be covered would be the sum of the lengths of the two objects. As simple as that. So if this is a train and this is a platform, then the distance that the train needs to cover to cross this platform would be the sum of the lengths of the two objects. That is the length of the train plus the length of the platform. So in this case, as I said, if it's a man, you can just consider it to be a point. If it's a pole, again, just consider it to be a point. And don't worry about when the man is moving or stationary, whatever. We can install, if the man is moving, we'll simply consider relative speed. If you understand the basic concept of relative speed, this is what it is. So when you have relative speed, it is the relative distance. So the relative distance is the sum of the lengths of the two objects. So in this case, the relative distance would be 100 meters. What I mean by relative distance is the train is not actually traveling 100 meters. It is traveling 100 meters with respect to the man. So it's covering 100 meters with respect to the man with a relative speed of the train is covering or traveling with a speed of 30 km per hour and the man is traveling with a speed of 6 km per hour in direction opposite to that of the train. So when it is moving opposite, this covering 30 km every hour and the man covering 6 km every hour. So every hour, the gap between these two should reduce by 36 kilometers. So the relative speed would be 36 km per hour. Let's make a small conversion out here because this is in meters and this is kilometer per hour. I hope you're aware of this conversion. 1 km per hour is basically 5 by 18 meter per second. Not tough to figure this out. 1 kilometer is 1000 meters. 1 hour is 3600 seconds. So you can just make that conversion, but better you remember this, not to convert every time you face a question like this. So just convert this. So 36 cross 5 by 18 meter per second. So this gives us 10 meter per second as the relative speed. Relative distance is 100 meters. Time would be relative distance upon the relative speed. So 100 by 10, that would be 10 seconds. So just remember, whenever you have one object crossing another object, the distance or the relative distance that needs to be covered would be the sum of the lengths of the two objects. Always, irrespective of whether the objects are moving in the same direction, opposite direction, or one object is moving, the other is stationary. It doesn't matter. The sum of the lengths would always be the relative distance that needs to be covered. And depending on whether you have both the objects moving or one object moving, you consider relative speed or simply the speed of the moving object. So that's it for today. I hope both was understood. Thank you for joining. If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.